This is the homework help video for 4-4 practice applications of linear systems. Okay, as you probably can tell, we're now in the thick of Algebra 1. This is what it's really getting to be all about. Okay, we're doing lots and lots of word problems. We've shown you all the ways you can put stuff in the calculator, but if you can't interpret the word problem and get the equation that you will eventually put in the calculator, you're out of luck. So I want to go over some of the strategies we've been going over in class many times, and there'll be a PDF of this right with your homework that you can download, put on your phone, and refer to. Okay, so some word problem strategies. First of all, read the problem carefully and then look to see if one of these patterns applies. Okay, and I'll be referring to this paper as we go through the odd-numbered problems on this assignment. Okay, the first pattern that you might look for is there a total of something in the situation? I'm talking about a total of people, a total of money, some kind of total of something. If there is a total of something, you're most likely going to be using standard form. Okay, we've done standard form as a pattern for quite a while, and that total that you found in the problem is going to be right here, the C value. Okay? And then once you figure out your variables, you'll be able to piece together the front of the equation, and I'll go into that at the end of this paper. Okay, that's my first strategy. Now, if there's not a total that you can find in the problem, go and try the next strategy. If there's not a total, then look for indications of a beginning value and a rate of change. Those should ring a bell from early in the year. Okay, the beginning value is our B number, and the rate of change is our M number in slope-intercept form right here. Okay, now you can often find the rate of change, the M number, by locating these words, either per, each, or every in the problem. The M number, the rate number, will be the closest number to that word, per, each, or every. Okay, and when we get to that in a word problem on this paper, I will point that out. Okay, so this is our slope-intercept pattern. This is what I begin with, or where I begin numerically in a situation, the B number. The M number is something that is going to be attached to per, each, or every. It's something that's also happening over and over again. You've heard me call this the over and over number. Now be careful when you find the slope number or the rate of change. Make sure you read the context of the problem to know if it's positive or negative. Okay? It may not necessarily have the negative attached to the number. It may be in the vocabulary in the problem itself. Okay? Lastly, if you don't find the first pattern or the second pattern, unfortunately, you may not have a pattern. Okay? There may not be a pattern. In that case, look for some common math words such as sum, more than, less than, is, etc. And you literally go through and circle these words and change those words into math. Each of these words means something in math. For example, sum means adding. Is usually the equal sign. More than, in this context, if I had 5 more than, it means I'm adding 5 to something. If I had 5 less than, it means I'm subtracting 5 from something. Okay? And again, when we get to this in the assignment, I'll point it out. Okay, lastly, a lot of people have trouble figuring out what the variables should be in the first place. To help you figure out what your variables should be, look at what the problem is asking you. They're usually asking you for the things that are the unknowns. And what is a variable? It's something we don't know. Okay, we figure it out by solving for it, and then we know them. Okay, so look at what they're asking you. That's usually going to give you a hint on what the variables need to be. So let's jump into the assignment and do the odds together and go from there. Okay, question 1. The concession stand is selling hot dogs and hamburgers during a game. At halftime, they sold a total of 78 hot dogs and hamburgers. So that's a total of both the hot dogs and the hamburgers. And brought in $105.50. How many of each item did they sell if hamburgers sold for $1.50 and hot dogs sold for $1.25? Okay, I'm going to go through my strategy paper and see what's going on here. First strategy, do we have any totals of stuff? We definitely do have totals. If you look at the numbers, I'm going to circle all the numbers just to get it out of the way. I have a total of 78 hot dogs and hamburgers. That's a giveaway. I also have the amount of $105.50. Then I have $1 hamburgers sold for $1.50. That's not a total, that's just for each hamburger, right? Hot dogs sold for $1.25. That's not a total. But this 78, it just straight up tells you. Now, they're not always going to be so nice to put the word total in there, but they did right now. A total of 78 hot dogs and hamburgers. So when they counted up all the hot dogs and hamburgers they sold all together, they ended up with 78, and that's going to go right here. So I'm going to put equals 78. Okay? The second number over here, it says, right after they said the total of hot dogs and hamburgers, they also said they brought in $105.50. That is the total money they got from selling the total hot dogs and hamburgers. So we have another total. Do you see how that works? So I'm going to have two standard form equations in this word problem. All right, now I know the standard form pattern is right here, but I'm stuck now. Maybe I don't know what to do. So what do? I look and see what the question's asking you. That will give me an indication of what my variables might need to be. How many of each item did they sell is what they're asking me. What items are they talking about? Well, there's only two items in the problem. Hamburgers and hot dogs. So guess what? Those are my two variables. You can pick whatever letters you want. Since they both start with H, I'm going to go with X and Y. I'm going to say X is the total number of hamburgers sold. I'm just going to put number of hamburgers. Y is the number of hot dogs. Okay? Now, if 78 is the total of all of them, guess what? All the number of hamburgers plus all the number of hot dogs is going to equal the total. So that's my first equation. X plus Y equals 78. Pretty easy. Now, also remember, whatever variables you have with all these system problems, you're going to use the same variables in the other equation. So I have some kind of X plus Y, but I can't add up hamburgers and hot dogs and get money. Here I added up hamburgers and hot dogs and got my total of hamburgers and hot dogs. But now I have to get a total of money. So we go to the other numbers in the problem. There's a dollar amount for each hamburger. Hamburgers sold for $1.50. So if I multiply my total hamburgers by $1.50, that's going to give me the money I made from hamburgers. If I multiply all my hot dogs sold by the $1.25, that gives me the money I made from hot dogs. So now it is money plus money equals money. Once you do that, that was the hard work. Now for the easy work, for the sake of time, I'm going to do LinSolve. And I already have x, y as my variables. So I'm going to put x plus y equals 78. Arrow down. 1.50x plus 1.25y equals $105.50. Push enter. That's your answer. Now, what does the answer mean? Well, X is the number of hamburgers sold. That's what I defined. And Y, 46, is the number of hot dogs sold. So, 36 hamburgers. I'm sorry, 32 hamburgers. I got the numbers mixed together. And 46 hot dogs. All right. Let's go down to number 3. There are 2 different jobs that Jordan is considering. The first job will pay her $4,200 per month. Oh, I see the word per. If there's not a total in that problem, I might be looking at strategy 2. Look for per each and every. That's going to be my M number. All right? Plus an annual bonus of $4,500. Okay? The second job pays $3,100 per month, another per. plus $600 per month. Oh, that's another per. That's interesting. Toward her rent and an annual bonus of $500. Which job should she take? All right. So we're going to have two equations. I'm thinking, I don't have any totals here, so I'm probably using y equals mx plus b. Remember, b is my beginning value, also known as my starting value, or I also call it the one-time number. It's something that happens only once in a situation. Let me remind you of this sheet from the beginning of the year. The b, you can put a 1 right on top of the b. That happens once. And the m is something that happens over and over again. So if it has the word per with it, it's happening over and over again. Per month. It's every month. Okay? So for equation 1, the first job will pay her $4,200 per month. That's over and over again. That's the number closest to per. That is my m number. So guess what x is? X is the number of months per month. I just defined x, number of months. Okay? Plus, well, we know what plus means in math. It means plus. An annual bonus of $4,500. That's only happening one time each year. So that is my B number. Okay, now what is Y? Y, there's only two things in this problem. There's months involved and there's money involved. So Y is going to be the total salary. Okay? So the next equation, we're going to have another pattern probably because we have the word per. Now we have the word per twice. There's a couple of ways you could do this. The second job pays $3,100 per month. This is happening over and over every month. But this is also happening over and over every month. You could just add these together and it becomes the m value, the rate, because they're giving the person both of these amounts every month. So if I add that together, it's $3,700. That's probably the most straightforward way to do it. Or you could put mx plus b. You could do that also. Separate it out and then combine the terms. Whichever way you prefer. Her annual bonus, that's only happening one time per year, each year, is the $500. So that is the B value for that. Okay. Now, do we have to Lin solve this? Do we have to find the solution? What are they asking? Which job should she take? Well, just based on money, you're getting a whole lot of money every month, and you're getting a whole lot of bonus every year. Here you're getting less money every month, and you're getting a much smaller bonus every year. Actually, without even having to go any further, we can answer the question they're asking, and we would say the first job is probably the one she wants to take if she wants the most money. Okay? So sometimes you don't even have to solve all the way to figure out what they're asking. Okay, let's go to the next one. If I run short and get to my 15-minute mark, I'll start a video part 2 to finish this. Okay, number 5. One plane is at 520 feet, and it's ascending at a rate of 40 feet per minute. There's the word per. While another plane at 3,800 feet is descending at a rate of 120 feet per minute. There's another word per. How long will it take for the two planes to be at the same altitude? Okay, so we have some vocabulary, math vocabulary we don't often see in every problem. We have ascending and descending. We're going to have to deal with that. Ascending means it's going up, and that would be a positive direction. Descending is going down, that it would be a negative direction. Okay, we have to keep that in mind as we piece together this equation. Okay, since we're dealing with the word per, I'm going to go back to my strategy reference page. That would be strategy 2, where we're dealing with probably slope-intercept form, okay? Which means we probably have a beginning or starting value of where the planes were, and we also have a rate, and that rate is going to be probably close to the word per each or every. Okay, so I'm going to go ahead and jot my pattern down here to kind of keep track of. And I'm going to continue this video on the next video.